Welcome to This Explainer. We're diving right into the dramatic, almost unbelievable underdog story behind the technology that is literally reshaping our entire world right now. It's a story filled with decades of academic rejection, a few incredibly stubborn mavericks, and one explosive breakthrough that fundamentally changed how we interact with machines forever. $44 million. Back in December of 2012, Google dropped this massive sum at an auction. But here's the kicker. They weren't buying a massive factory, and they weren't buying some booming viral app. Nope. They bought a tiny, three-person startup operating out of a hotel room in Lake Tahoe. And the absolute craziest part? This startup had zero products and absolutely no plans to ever build one. So what could possibly make an idea worth $44 million to one of the biggest tech giants on the planet? Well, we're going to explore exactly how the neural network, an academic concept that mainstream science practically laughed at and ignored for decades, suddenly became the single most valuable idea in the entire tech industry. To understand how this idea completely flipped our worlds upside down, we'll hit a few key beats. 1. The birth of the neural network. 2. Surviving the AI winter. 3. The deep learning explosion. 4. Real-world applications. And finally, 5. The future and its flaws.
Number 1, the birth of the neural network. Let's rewind the clock all the way back to 1958.
Long before the sleek little smartphones we carry around today even existed, our story kicks off with a researcher named Frank Rosenblatt. As detailed in Cade Metz's incredible book Genius Makers, Rosenblatt built this massive, room-filling machine for the U.S. Navy. And let me tell you, the press hyped this thing to the moon. Newspapers were running wild headlines, extravagantly calling it a Frankenstein monster designed by the Navy that thinks, walks, and could even eventually reproduce itself. Crazy, right? But the reality behind all that sci-fi hype was a system called the perceptron. Basically, it was an early mathematical model based on the human brain's network of neurons, and it was designed to learn simply by finding patterns. But Rosenblatt's actual physical machine, it was pretty rudimentary. It could identify marks on a punch card using simple photocells. The real bottleneck, though, was that it relied on just a single layer of artificial neurons.
Number 2, surviving the AI winter, which was essentially decades of total obscurity for this tech.
Despite that initial burst of excitement, this single-layer technology quickly hit a massive, seemingly unbreakable wall of skepticism. In 1969, a very prominent MIT skeptic named Marvin Minsky published a book that pointed out some fatal mathematical flaws in the perceptron. And man, the academic community just piled on. Research funding froze almost overnight, and neural networks were banished to decades of total obscurity. Scientists actually refer to this brutally cold period as the AI winter. The fatal flaw Minsky found was all about the architecture. He proved a single-layer network couldn't even solve basic logic puzzles, like it couldn't even figure out if two spots were different colors. But a few stubborn mavericks, like researcher Geoff Hinton, just kept quietly pushing forward in the shadows. They realized that multi-layer networks were the key to solving these complex puzzles. To get multiple layers to actually communicate and work together, they developed a really brilliant calculus-based trick called backpropagation. This basically allowed mathematical feedback to cascade backward down a hierarchy of neurons, constantly adjusting, tweaking, and learning. So how does a multi-layer network actually build an understanding of the world? Imagine feeding a photo into a computer. Step 1. The very first layer of artificial neurons analyzes the raw pixels, just recognizing black, white, and brown. Step 2. It feeds that super basic data to the next layer, which identifies tiny lines and arcs. Step 3, the network combines those arcs into more complex shapes, like maybe an ear or an eye. And finally, step 4, it pieces that whole puzzle together to confidently say, hey, that's a dog. It brilliantly breaks complex ideas down into sequential visual blocks. Number 3, the deep learning explosion, brought to you by a very unexpected hardware savior. See, for decades, these multi-layer networks completely stalled out simply because they didn't have the sheer processing power needed to crunch through thousands of images. That is, until a savior arrived from the video game aisle. Seriously. Off-the-shelf video game chips, GPUs, proved to be absolutely perfect for this. Chips designed by companies like NVIDIA to render fast-paced, intense graphics for games like Grand Theft Auto, turns out they provided the exact accelerated parallel processing power needed to train massive neural networks, a total game changer. Old ideas are new. That was Geoff Hinton's mantra.
Armed with these powerful gaming GPUs and the massive avalanche of data suddenly available on the internet, Hinton and his 2 graduate students built a multi-layered network that absolutely blew away the competition. They entered a major 2012 computer vision contest called ImageNet and won by a staggering margin. Hinton effectively proved that his old ideas, the exact ones that had been ridiculed for 30 years, were finally ready to change the world. And you better believe the tech world noticed immediately. As researcher Andrew Ng put it, "I now believe intelligence is something we can recreate in our lifetime." This undeniable ImageNet breakthrough sparked a frantic global arms race. Tech giants like Google, Microsoft, and Baidu were scrambling, desperately trying to acquire deep learning talent. Oh, and that $44 million auction we talked about at the very beginning? Yep, that was Google buying Geoff Hinton and his 2 students just to secure their expertise.
Number 4, real-world AI applications, taking the theory and making it a reality.
It felt like almost overnight, this obscure academic theory transformed into tools we now use every single day. Suddenly, neural networks were powering the digital assistants on our phones. They were enabling instant language translation. In massive warehouses, researchers trained robotic arms to seamlessly sort distinct items. And over in the medical field, AI actually began successfully screening for things like diabetic retinopathy, catching early signs of blindness. This leap from abstract theory to tangible reality was truly unprecedented.
And finally, number 5, the future and its flaws, looking inside the black box.
As this incredibly powerful technology continues to scale up, it's bringing some unpredictable new challenges with it. One major hurdle we're dealing with right now is the rise of generative adversarial networks, or GANs. Rather than just recognizing images, these networks can actually generate them from scratch. They can create highly realistic, totally fake photorealistic faces or perfectly duplicate the voices of politicians. And while the underlying tech is undeniably remarkable, it opens a pretty dangerous door to automated misinformation, deepfakes, and weaponized surveillance on a massive scale.
Furthermore, there's a really fierce debate happening right now about the actual intelligence of this AI. Critics like researcher Gary Marcus point out a pretty fundamental flaw. Deep learning currently requires millions of meticulously labeled examples just to learn a very basic concept. A human toddler, on the other hand, they learn from tiny amounts of data because of what Marcus calls innate machinery, basically a biological structure that evolved over millions of years. Neural networks, for all their raw processing power, still currently lack this innate biological common sense. Which really leads us to the ultimate question here. As we continue to push the boundaries of this $44 million idea, we're left wondering, will feeding these neural networks simply more data and faster processing power eventually equal true understanding? Or will artificial intelligence always just be an incredible pattern-recognizing tool that fundamentally lacks human common sense? Honestly, it's something to think about the next time your digital assistant answers your question. Thanks for joining me on this explainer, and remember to keep questioning the technology around you.